I was actually walking past a playground yesterday and had this visceral memory of the merry-go-round. Do you remember the terror of that thing?
Trying to just hold on for dear life.
Well, trying to make it go faster mostly. Like, I remember standing on the dirt waiting for a handle to whip by
And just grabbing it while running.
yeah, you'd get yanked right off your feet, but suddenly you were flying way faster than you could run on your own.
That playground physics is actually a perfect entry point for what we're looking at today, because you were essentially stealing momentum from a massive object to boost your own speed.
Right, and in astrophysics, that's called a gravity assist or a celestial slingshot.
Exactly. We've got a great stack of research on orbital mechanics today to really figure out how we get something for nothing in space.
Because getting robots to the outer solar system without massive fuel tanks, it's the only way we get there within a human lifetime.
It is the only way.
But see, something for nothing always sounds like a scam to me. Physics usually doesn't let you get away with that, right? There has to be a cost.
Oh, you're totally right to be skeptical. Nature always balances the books. We aren't creating energy here. We're actively stealing it.
Stealing it from the planet.
Yep. We are robbing Jupiter to pay Voyager.
I love that.
The sources actually use a really clear analogy for this, the tennis ball and train. So picture you are standing on a train platform. A train is rushing towards you at, say, 50 miles per hour.
Okay.
And you throw a tennis ball right at the front of that train at 30 miles per hour.
Assuming the driver doesn't call the cops, the ball hits the train.
Right, so focus on the physics here. From the train driver's perspective, the ball hits them at 80 miles per hour.
Yeah.
It's the train speed plus your throw speed.
Yeah, it makes sense.
And it bounces off the front at that exact same 80 miles per hour. Simple reflection. But you are standing on the platform.
Oh, right.
You see that ball leave the train, which is also moving at 50 miles per hour. So you get the bounce speed of 80 plus the train speed of 50 added on top.
So it rockets back at you at 130 miles per hour. That is a massive jump.
It is. The train effectively transferred its momentum to the ball. And when a spacecraft flies by a planet relative to the sun, our platform, it steals a chunk of the planet's momentum.
But wait, does that mean we are slowing the planet down? Like, did Voyager actually hit the brakes on Jupiter?
Technically, yes.
Yeah.
But Jupiter's so massive, the trade-off is almost comical. For every kilometer per second of speed a spacecraft gains, Jupiter slows down by roughly 1 foot per trillion years.
So Jupiter doesn't even notice.
Not even a little bit.
Yeah.
But it allows us to do incredible things. Timing is everything, though. Voyager only worked because of the Grand Tour.
Which was a rare alignment of Jupiter, Saturn, Uranus, and Neptune.
Yeah, it happens once every 175 years. It let Voyager bounce from one to the next, just picking up speed at every single stop.
So if we had missed that window, we'd just be grounded for nearly 2 centuries. It really emphasizes how much of space travel is about optimization and seizing the perfect path forward.
Absolutely.
And speaking of optimization, that actually reminds me of our sponsor, Embersilk.
Oh, great connection. If you are looking to streamline your own operations, whether that's AI training or automation or complex software development, Embersilk is definitely the partner you need.
Yeah, they are all about uncovering where agents can make the most impact for your business or even your personal life. Check out embersilk.com for your AI needs.
So getting back to gravity assists, most people think they're just about hitting the gas pedal. But you can also use them to slam on the brakes.
I saw that in the notes on the Messenger mission to Mercury, because Mercury is incredibly deep in the sun's gravity well.
Right. If you fly straight there, you pick up way too much speed to stop. You just blow right past it.
So Messenger used flybys of Earth, Venus, and Mercury itself to do the reverse of the train analogy, giving momentum back to the planets to slow down enough to actually enter orbit.
Exactly. And then you have the Ulysses mission, which didn't use Jupiter for speed or braking. It was a geometry problem. They wanted to see the sun's poles.
But Earth orbits the sun's equator, and we just don't have rockets powerful enough to fly straight up and over the sun.
Right, so they flew to Jupiter and used its massive gravity to fling the spacecraft practically vertical out of the planetary plane entirely.
That sounds incredibly precise, like terrifyingly precise piloting.
The margin for error is razor thin. The sources describe it as hitting a keyhole. You have to hit a specific point in space, sometimes just a few kilometers wide after traveling millions of miles.
And if you miss, you crash, or you just get flung into empty space with no way home.
Very high stakes. But look at the result. It completely democratizes space travel. We used to think only massive rockets could do this, But now smaller missions like New Horizons can reach Pluto.
It really proves that human ingenuity can navigate the absolute laws of the universe to explore the stars. We aren't fighting gravity.
We're dancing with it.
I love that. So here is a positive thought to leave you with. If we can steal momentum from planets to travel through the dark, what other cosmic forces are out there?
Just invisible currents waiting for us to figure out how to hitch a ride.
Exactly. The universe is incredibly open to us. If you enjoyed this deep dive, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.